This video is a short introduction to the Unix command line. This is for people who are already familiar with Windows or the use of Windows interface in Linux. Let us first answer the question of why use the Unix command line interface as opposed to the Windows graphical user interface. After all, a Windows based GUI is available in Linux as well and it looks better. So why not use that? The issue is that if you use a Windows GUI, you are using a pre-programmed interface and the set of possible actions has already been decided for you by the programmer at the time of programming. As opposed to this, if you use a command line shell, the shell is nothing but a programming language or a scripting language. It means that you can not only use pre-written programs written by other people, you can also compose these pre-written programs into new scripts of your own. The ability to write new scripts gives a whole new dimension of power to the user and flexibility in usage. This flexibility can be illustrated easily through a few examples. Let's look at this first example where I want to rename a set of files. Here in this folder, I have a set of JPEG images, photos I have taken. This command gives me the number of files which are there. There are 65 files in all. I want to rename all of them to prepend the word large in front of each file name. So let's see how to do that. To do this, the command line user just has to write a for loop as follows. For f in star, do move $f to large dash $f. Move is the command for renaming a file and done. Now let's do ls and we're done. As you can imagine, doing this using a Windows GUI based interface would be much more difficult and time consuming. Let us look at a second example of the power of the command line shell. Here I want to count the number of lines in all the C files in a particular directory. So here I have a whole bunch of C code files as well as header files. In order to count the number of lines in all the C files, what I have to do is this command. This is actually using two commands and composing them into a new program altogether. The first is the cat program, which simply outputs each of the C files given to it in the command line. And the second one is a program called word count, which with the flag -l counts the number of lines. The cat program outputs something to the word count program and the result of that is the output we want, which is 3279 in this particular case. Again, as you can imagine, doing this without a command line interface would be far more difficult. Continuing along the same lines, let's look at a third example where we want to find the top 5 files with the maximum number of lines. Here let me come back to this directory. To find the top files with the maximum number of lines, what I have to do is the following. It is this command. So here I am composing 3 pre-existing programs. The word count program, which counts the number of lines in each of its arguments. Then I am sorting the output of this word count numerically, that is the -n flag, and I want the top 5 of these. I actually give an argument of 6 here, which will become clear shortly. That's because this word count program prints this one, which I have to ignore. So the output I want is this. These are the 5 files which have the maximum number of lines in this particular directory. To state the obvious, what we did in the matter of few seconds using the command line interface would have taken far more time and nobody would be inclined to do it without a command line interface. Let us now learn a few basics of the usage of the Unix command line. The first step is to open a command line. This depends on what window manager you are using. In GNOME, I have to go to this application menu and accessories and open terminal. This opens a terminal for me. Another way to do it is to press Alt F2 and type GNOME terminal. Once you have a command line open, you can start using this for invoking various commands. Let us first look at a set of basic commands for various file and directory related operations. The command pwd prints the current working directory, which in this case is /home/br. This is my home directory. The home directory is the directory with which the command line terminal starts. You can use the command cd for change directory. I can now go to the directory which I used for illustrating the previous examples. Notice now that I am using the tab key. I have started typing the first few letters of the directory I want to change to, and press tab. It does what is known as autocomplete. This is a very useful feature. Again, I press CO and then press tab. It auto completes it for me. Now I am in this particular directory. You can also see that the command line prompt prints the current working directory. This depends on your setup of the command line terminal, which we won't get into in this video. Next is the ls command, which we have already seen in some of the examples. ls lists the set of files and directories within this directory. By default, ls hides some of the entries in the directory. I can unhide them, list everything by using this -a option. If we look at this, we see two entries, dot and dot dot. These correspond to the current directory. Dot stands for the current directory and dot dot stands for the parent directory. So for example, if I do cd dot dot, I will go to the previous directory, the parent directory of the current directory. I can make a new directory by using the command mkdir for make directory. So here I see the new directory which has been created. If I want to remove it, I can do rmdir and it is now gone. A little bit more on file related commands. Here I have created a file called testfile.txt. If I want to look at the contents of the file, I can use the command cat testfile.txt and it will show me the contents. Of course, as you see here, the contents are scrolling before you can view them. So a more sophisticated version of cat is this program called less, which if you use, it will provide you a scrollable interface so that you can read it by scrolling back and forth. You can use the command cp for copying a file from source to destination. You can use the command move mv for moving from source to destination. The command ln is for linking a file. It is usually used with the flag -s. This is for a soft link, which is similar to the Windows shortcut feature. ln-s source to destination. Now if I look at all of the text files, you can see that t3.txt is a soft link to t2.txt. What this means is that if I edit t3.txt, it is the same as editing t2.txt. Let me delete the first line here. You will see that the first line has gone away from t2.txt as well. You can use the command rm for removing. It is usually safe to use rm with the flag -i, which is for interactive. Let me now remove these two files. I can also remove soft links similarly. This -i makes the program ask the user each time before it deletes a file. So those are the basic set of commands you need for file and directory related operations. The command line can be used for invoking other programs as well. The way to do that is you type the command. Here I have typed the emacs command with the argument testfile.txt, then use ampersand and press enter. This will open the Emacs editor in another window, and the old command line window is still available for you to type further commands. You can look at what child processes are running in a particular shell by using PS, which stands for process status. Here it is saying that Emacs is running, it's one of the processes which are running under this particular shell. I can use the command kill to kill a particular process. To kill the Emacs process, I do this, that's the process ID, and you can see that the Emacs window has disappeared now. And typing a further PS will say that there is no Emacs, and the command line also prints that Emacs has been terminated. Let's look at a few more useful commands. The WC command I have already introduced to you through the various examples. One very useful command is the tar command. Let's look at an example of how to use this tar command. It is the equivalent of the Windows zip feature. Now let us say that I want to make all of the contents of this particular directory into a single file, a zip like file, maybe in order to email it. What I have to do is go to the parent directory and issue the command like this. Now it has created the file code.tgz. Now let me explain a little bit of this command. These are the various options of tar. Z stands for zip, which is a mode of compression. C says this argument and its contents have to be put into this particular file. V is for verbose, and F says that this is the file which should be the output of the zipping process. Now I can untar the same file to get the original contents. Let's try this. I am going to copy this code.tgz to my home directory, go to my home directory and issue the command like this. Here the arguments are the same as earlier except for X, which stands for extract from the given archive. Now I have the original contents of the directory in this directory code under my home directory. Another useful command is this command called grep, which is used for finding patterns within files. So let us say that I want to find all calls to the system call socket within this set of C files. I have to do grep socket star.c, and it prints all instances of socket calls as well as this hash include. Wherever the string socket appears, it prints those lines. Now one command which I have saved for the last for explaining is in fact very important. All of the previous commands which I have introduced, such as ls, rm, mv, cp, cat, less, tar, grep, wc, everything, they have a lot of options, command line options, using which you can tweak their functionality. Now, how do you learn of what command line options a particular command has? So for this you use this man command, which stands for manual page. So suppose you want to learn about the command grep further, you can do man grep and it will give you a whole lot of information about what are the command line options taken by grep and what the various functionalities are under these different command line options. Similarly, you can do man tar to find out what are the different options for tar. So man is an extremely useful command for learning about various other commands. Let me now touch upon file permissions and access control in the Unix file system. There are three kinds of permissions in the Unix file system for each file or directory, and there are three levels of access control. These are best illustrated by examples. So let us look into this here. So here I have a hello world program called hello.c, which I have compiled into a program called hello. And here I am going to focus on these entries which give permissions for different levels of access control. So the first bit here is the read flag for the owner of the file. The owner of the file in ls-l is given here, which is br, which is my user ID. The group of this file is again BR, a group called BR in this particular case. The group's read, write, execute permissions are given in this second set of 3 flags. Here I see that this particular file hello is readable and writable by the owner as well as executable by the owner. The same set of permissions are applicable for the group BR as well. For the rest of the world, it is readable, it is not writable, and it is executable. Likewise, this file hello.c has read and write permissions turned on for the owner of the file, which is BR, and for the group of the file, which is also the group BR, it also has read and write permissions and no execute permission. For the rest of the world, it has only read permission. Now, what is this flag here? The very first one, it indicates whether or not the file is a directory. So here I have created a directory called testdir. The contents of testdir can be seen by using this ls-la command. You can see that the contents include dot, which is the directory itself, and this D flag here is saying that it is a directory, and likewise this dot dot, the parent directory of testdir, is also a directory. And you can see that execute permission is usually turned on for directories. In fact, for changing into a directory, you need execute permission for that directory to be turned on. So to summarize, each file or directory has read, write, and execute permissions, and each of those is specified for the owner of the file, the user, the group owner of the file or directory, and for the rest of the world. So that's it. You are now all set to explore the world of Unix command line.